Hi, I'm Jim McDonald from Texas Instruments, and today I'm going to be talking to you about digital power and specifically about PMBus. What I brought with me is a PMBus system demonstration that I'm going to show you using 3 different eval boards specifically from TI. Over on the screen is a visual representation of this demo, and what we have is 3 different eval boards that are all connected together using the same PMBus interface. On the left is the LM5066 hot swap controller. In the middle is the UCD3138 digital PWM controller. And on the right is the TPS40422 non-isolated DC-to-DC controller. All 3 of these boards support the same industry standard PMBus interface. So now let's show you how these boards interact together. Again, on the left is the 5066 hot swap controller that takes 48 volts and protects the system against harmful inrush currents. In the middle is the UCD3138, which takes 48 volts and converts it down to 12 volts. And on the right is the TPS40422 DC-to-DC controller, which takes 12 volts and creates 2 different output voltages for powering digital loads. And the ribbon cable here represents effectively the PMBus interface, which is common to all 3 of these boards. So now let's go over and take a look at the graphical user interface that's used to interface to all 3 of these boards. As you can see here, up on the top, we have visual representations of the LM5066, the UCD3138, and then on the right, the TPS40422. Down below, what we're doing is we're monitoring and displaying the input voltage coming into the system over here through the LM5066. In the middle, we're displaying the 12-volt intermediate bus. And on the right, we're displaying the 2 output voltages, one being 3.3 volts and the other is 1.2 volts. Down below on the right, we are showing that there are 2 loads connected to those 2 output voltages. They are both static loads, one at 5.5 amps and the other at 3.3 amps. But what I can do now is I can change my load on one of those output voltages so that we can monitor the difference, and we can see that dynamically, as things happen in the system, we're visually representing that change on the GUI. So then let's take a look over back on the LM5066 output, because as you can see over on the left, as we've made those changes to the load, we see that the input current coming into the system is now varying, something that we would expect. So then one other feature of this system is the ability to represent fault conditions. So what I'm going to do is I'm going to change the input voltage from 48 volts down to something that's below the 40 volt undervoltage lockout threshold so that I can see whether the system recognizes a fault. And what you'll see in the top left is as I do that, we've gone ahead and tripped a fault condition, and we visually represented that with the undervoltage fault flag, showing that something is wrong with the system and it's alerted me that I need to change something. So the first thing I'm going to do is reset it, and then I'm going to raise the voltage back up to the nominal 48 volts. And then the last thing I'm going to do is I'm going to clear the faults because I want it to go back into normal operating conditions. And as you can see, the fault has cleared, the red flag has gone away, the input voltage has gone back to 49 volts, and everything is operating as expected again. So these are just a couple of things that you can do with these flexible eval boards. For more information on any of these products, or for more information on digital power or PMBus in general, please go to ti.com/digitalpower. Thanks very much for your time.